Thank you for joining us. Today, our Senior Research and Development Chemist, Joe Stoller, and I will discuss the benefits of choosing ProPreg E240 over polyester on PEEK-Insulated magnet wire for e-motors. I will start out by telling you a little bit about EPIC Resins. EPIC is located in southeast Wisconsin. We have been a custom formulator and manufacturer of epoxy and polyurethane materials since 1958. With over 60 years of formulating, we have a profound understanding that not every application is the same. Our experienced team of chemists can formulate or adjust our current products to meet your application requirements. We do this by utilizing our cutting-edge laboratory, which includes FTIR, multi-mass spectrometer, nuclear magnetic resonance, TCI, thermal chamber, DSC, TMA, Instron, HiPot, and other electrical testing equipment. All testing is done in-house on our equipment to ASTM standards. Our production and warehouse facilities include approximately 75,000 square feet. This houses over 10 high-speed dispersers, multiple vacuum pumps, and our farm of raw material bulk tanks. EPIC's core chemistries are epoxy and polyurethane thermoset materials. We have well over 3,000 epoxy and polyurethane formulas and service over 1,500 customers worldwide in 6 continents. EPIC Resins is ISO 9001 and 14001 certified. EPIC Resins has provided proven thermal management solutions since the 70s. Our products for e-mobility provide solutions for many applications, including motor, battery, transmission, sensors, and ECUs. Now let's look at current trends in e-mobility. Shifts to EV transportation, whether it is ICE to EV motors, bicycles, and LEV manufacturers are moving quickly. Manufacturers are moving to increase electric vehicle range by using better cell technology and improving motor efficiency. There is also a need to decrease battery charging time. This is made possible through cell technology and charger improvements. The industry is moving towards higher performing e-motors with increased voltages of 800 to 1200 volts and improved motor designs. Creating miniaturized and lighter weight components with lower weight potting compounds and sealants is increasingly important. With these industry changes, many manufacturers are also moving to PEEK-coated wires. PEEK-coated wires have many benefits, including an improved power output. Using PEEK-coated conductors in combination with rectangular wire can increase copper slot fill over typical round wire utilizing polyester polyamide enamels by over 10%. PEEK-coated wires are also more efficient. They have a higher thermal conductivity than typical enamel-coated wires and aramid papers. PEEK has a thermal conductivity of 0.35 watts per meter K versus 0.1 watts per meter K of aramid papers. PEEK also provides the same electrical resistance as aramid papers at 2/3 the thickness. Another strong benefit of PEEK is its reliability. PEEK-coated conductors have no pinholes due to the coating process when compared to enameled wires. PEEK can provide a higher coating thickness than enamel wire, providing an increased PDIV protection. PEEK-coated wires are resistant to ATFs, especially those that include small percentages of water. As the EV industry began to look at PEEK-coated wire, it was clear that the industry-leading polyester did not perform well on engineered plastic-coated wires, especially rectangular hairpin types. The brittleness of the polyester and inability to wick into the stator slots due to the low surface energy of the PEEK reduced slot fill of the polyester by over 15%. Poor adhesion and mismatched TG of the polyester caused flaking off of the polyester from the interns when the motor was in service and while being cooled with ATF. EPIC Resins was approached with finding a solution to challenges that the widely used polyester resin was not able to overcome. The first was an increase of adhesion to PEEK at temperatures up to 240 degrees C without cracking or flaking. The material must also reduce CTE mismatch and increase TG from industry-leading polyester, approximately 55C, to higher TG, closer to PEEK with an epoxy. It is vital that the material must drop in with the existing trickle equipment without a loss of process throughput. It must also be able to maintain, or better yet, reduce cure cycle time and lower the oven temperature in the bake zone. It is important that the material be cost competitive with leading industry polyester acrylate and be a single component with good shelf life at 25C. Having a UV tracer for visual and video monitoring is vital in processing. ATF resistance is also a key property, maintaining both the mechanical and electrical strength needed when submerged in ATF and in ATF vapor at 150 degrees C and aging for 2,000 hours. Joe Stoller will now begin discussing the chemistry of the ProPreg E240.
Thank you, Jeff. EPIC Resins' focus is on building custom polymer solutions to solve these types of industry challenges. When we start the design and development process, we first examine the challenge an industry or application is experiencing. Once we have identified the critical properties that will solve this challenge, we then analyze how unique changes to the chemistry of the polymer can solve the problem. In most cases, this not only leads to a solution, but in many cases improves the overall performance of the application. For this application, the industry needed a polymer that would have a similar process requirements to standard polyester insulation materials, but also have improved adhesion to PEEK, as well as improved thermal stability over polyester. We will start our introduction of ProPreg E240 by discussing the basic chemistry of the polymer system. First, ProPreg E240 is a single component, high-performance epoxy secondary insulation. E240 was designed to have the high performance of a two-component epoxy with the handling properties of a single component. Secondly, EPIC E240 is 100% reactive. This is an important distinction in that there are no plasticizers or solvents. Systems that are not 100% reactive will display excessive shrinkage, reduced insulation thickness, as well as reduced thermal resistance and less durability overall. Because E240 is 100% reactive, all of the polymer that is applied becomes insulation. Because E240 is 100% reactive and contains no solvent, it has little to no odor. The most critical chemical property of ProPreg E240 is the molecular structure. At EPIC Resins, when we design solutions for a customer, we start at the molecular level. E240 was developed from the molecular structure property relationship to optimize thermal properties. The molecular structure of E240 was engineered to contain saturated tetrafunctional linkages. These linkages contribute to E240's significant mechanical and thermal durability. Developing polymers from the molecular level allows us to tailor the cured properties of the polymer to yield optimum performance for the final application. Due to the thermally demanding nature of this application, thermal durability of the polymer was the primary design criteria utilized to develop ProPreg E240. We will start by discussing the thermal-mechanical properties of ProPreg E240. The thermal-mechanical analysis, or TMA, measures dimensional changes in a material when ramped through a temperature range. In measuring thermoset epoxy polymers, the TMA measures the glass transition temperature, or TG, and the coefficient of thermal expansion, or CTE, of the cured polymer. The TG is the temperature when a material changes from a rigid glass-type material to a soft pliable material. The CTE is the rate of expansion over a temperature range. As we look at the TMA of E240, you can see that before the TG, from minus 40°C to approximately 130°C, E240 has a constant rate of expansion, or CTE, of approximately 48 part per million. As the temperature continues to ramp, you see a deflection at the curve at 133°C, indicating the TG of E240. After the TG, as the temperature ramp continues, you see a second constant rate of expansion known as the post-TG CTE of approximately 208 part per million. When we overlay a polyester onto the graph, you can see a distinct difference in the TG. The TG of the polyester is significantly lower than E240 at approximately 53°C. A lower TG indicates a lower degree of cross-link density, which yields lower thermal stability and reduced chemical resistance. Additionally, when you overlay the TMA of E240 with PEEK, you see that they have a much closer pre-TG CTE, TG. Another thermal analysis tool that is used to identify potential improvements to a polymer is TGA. The thermal gravimetric analysis, or TGA, measures how a material loses weight at different temperatures and ultimately the thermal degradation of a polymer. It is this measurement of thermal degradation that was one of the critical design criteria for a polymer to operate up to 240 C. As you can see from the TGA for E240, it has very little weight loss up to approximately 200 degrees C. If we look more closely at the temperature range, you will observe that up to 200 C, E240 has retained over 99% of its weight. When we overlay the polyester, you can see a significantly higher degree of weight loss. The polyester loses approximately 3 times more weight than E240, up to 200 degrees C. This indicates that at elevated temperatures, E240 will have better performance, durability, and longevity than standard polyester insulation. Adhesion is a critical property for secondary insulations. As applications become more demanding, more power is required, and hence more applications are turning to PEEK-insulated wire and slot liners. The low surface energy of PEEK makes it difficult to bond to. ProPreg E240 was specifically designed to have a surface tension to associate and wet the surface of PEEK-coated wire and slot liners. The unique surface tension of E240 significantly improves the adhesion of PEEK-coated wire and slot liners compared to the leading polyester. The analysis conducted to test adhesion was a 180-degree peel test. As you can see from the illustration, a PEEK film is adhered using ProPreg E240 or polyester insulation to the metal conductor substrate. The PEEK film is then pulled at a 180-degree angle while the metal conductor is held in place. In the 180-degree peel test, you see in the graph that E240 obtains at least double the adhesion compared to the leading polyester. This adhesion improvement is due to the molecular functionality and its ability to wet the surface of PEEK. This wetting is illustrated in the image shown here. ProPreg E240 passively climbs up the PEEK-coated wire at a rate significantly higher than that of the polyester. Adhesion alone does not assure success as a secondary insulation. Adhesion must be maintained when exposed to elevated temperature conditions and harsh environments. For secondary insulation materials, this is tested using IEC 61033. This is a 61033 test specimen. As you can see in the illustration, this bundle is composed of 9 pieces of PEEK-coated conductor wire. This test is conducted by first constructing this wire bundle, followed by an insulation process that will mimic the manufacturing process. Once cured, the bundle is exposed to 2 different environments: elevated temperature exposure immersed in ATF and elevated temperature exposure to ATF vapor. Samples that were conditioned at each of these temperatures are then evaluated at different time intervals: 500, 1000, 1500, and 2000 hours. The integrity of the adhesion is then tested by the fixture in the illustration. This fixture measures the force required to break the center wire free, which mimics the wire in the slot. From the data collected, you can see that after 2000 hours at 150 C exposure immersed in ATF, over 91% of the original adhesion was maintained, and over 97% was maintained for ATF vapor exposure. Additionally, during analysis, separation took place between the PEEK coating and the copper wire, while the bond between E240 insulation and PEEK coating remained intact. The results indicate that the E240 insulation PEEK bond strength was greater than the PEEK coating tensile strength and the PEEK copper bond strength. In addition to elevated temperature exposure testing, we also conducted IEC 61033 wire bundle test at various temperatures: 25 C, 150 C, 180 C, and 240 C. During this testing, E240 did not fail or pull loose from the bundle at any temperature. As seen in the graph, the polyester failed at 70% lower strength than the yield point of E240. Also in the graph, you will see a distinct reduction in the bond strength of the polyester after 50 degrees C due to its lower TG. Additionally, the strength curve for E240 is parallel with the results for the copper wire, indicating that the bond strength is at least equal to the yield of the copper wire. This greater strength and performance is due to E240's higher TG and hence thermal stability over a polyester. In addition to mechanical durability, electrical durability in the form of dielectric breakdown was also a critical design criteria for this application. Electrical durability was tested utilizing a lashed pair dielectric breakdown test. This test is conducted by constructing a lashed pair wire test specimen as seen in the illustration, followed by the insulation process that will mimic the manufacturing process. Once cured, the lashed pair is exposed to two different environments: elevated temperature exposure immersed in ATF and elevated temperature exposure to ATF vapor. Samples that were conditioned at each of these temperatures are then evaluated at different intervals: 500, 1000, 1500, and 2000 hours. At each of these test intervals, samples were tested by applying a voltage between the lashed pairs and ramping that voltage up to failure, or 20,000 volts. As you can see in both immersed and vapor exposure, no significant dielectric breakdown was observed in the lashed pair test after 2,000 hours exposure. In addition to improved cured properties performance, ProPreg E240 also displays favorable health and safety benefits. The two most prominent differences are VOC and carcinogenicity. ProPreg E240 has a boiling point of greater than 320 degrees C and is thus a very low inhalation hazard. E240 is 100% reactive, contains no solvents. Additionally, ProPreg E240 does not contain any carcinogenic materials. Now that we have introduced the chemistry and developmental advantages of ProPreg E240, we would like to welcome Jeff Southworth back again to discuss how these advantages yield benefits in your process.
Thank you, Joe, for giving us an overview of the chemistry and safety data. I will now go over process considerations and help you understand how the EPIC ProPreg E240 compares to the industry-leading polyester and all polyesters for that matter. We will look at process parameters, critical properties, and how they affect the process and final condition of the stator. In this video, you can see the EPIC ProPreg E240 being applied to a conventional round wire stator using polyester, polyamide-imide primary insulation, wire enamel. See how well the E240 absorbs into the interns, and you can see on the finished product how well coated the interns are, and there is no resin migrating onto the end laminations or on the ID or OD area of the stator. Here you will see the viscosity versus temperature curves, which are key in a trickling process. The EPIC ProPreg E240 has a viscosity manufacturing specification range of 13 to 18,000 centipoise, while the polyester acrylate has a viscosity of 2,000 to 2,500 centipoise. Initially, when engineers see the noticeably higher viscosity of the E240, they become concerned with the wickability into the slots and how quickly the resin will absorb into the windings. You can see that beginning at 25C, the E240 starts out around 15,000 centipoise. When the temperature is raised to 30C, the epoxy drops to around 4,000 centipoise. As we continue up to 50C, the viscosity is now down near 750 centipoise. When the temperature is increased to 75C, the ProPreg E240 actually has a lower viscosity of 142 centipoise compared to the polyester with a viscosity of 152 centipoise. It is important to note that no manufacturer applies secondary insulation to an unheated stator, and that preheating the stator to 75C or above will result in both the E240 and industry-leading polyester having the same viscosity. Applying to the preheated stator will immediately assume the temperature of the stator and the viscosity will drop immediately. The types of pumps used are important for moving the ProPreg E240 to the dispense nozzles. Due to the higher room temperature viscosity, progressive cavity pumps and gear pumps are the best pumps for moving this epoxy, or any viscosity or material type. These pumps have better precision and accuracy. Peristaltic or diaphragm pumps can be used with the ProPreg E240. However, they are less accurate and will need to be sized for the specific viscosity range of the material. The EPIC E240 will dispense, flow, and wick into PEEK-coated wire much better than the industry-leading polyester, without dripping, backing out of the slots, or getting on in laminations, inside diameter or outside diameter. The resin will not bond the chuck fixtures. This can be attributed to the difference in surface tension due to the lack of solvents or acrylate monomer in the E240. Here you will see the viscosity after 20 minutes at 90 C. The industry-leading polyester has a viscosity of 3,275 centipoise. EPIC ProPreg E240 epoxy has a viscosity of 29,387 centipoise. This is important because polyester resins are notorious for dripping, backing out of the slot area, and just going places the motor manufacturers do not want the resin to go during the trickle process. Since the trickle area is not heated, the stator temperature will drop and the polyester will remain flowable even though the part is still rotating. Typical time in the unheated trickle and the total time for the stator to reach the bake area is approximately 10 to 25 minutes. The resin movement can take place all the way into the bake zone until the stator temperature rises to a temperature where the polyester will stop moving. This causes the cured stators to need additional cleaning and burnishing to remove the unwanted varnish. With the ProPreg E240, the reactivity is such that the epoxy will body up quickly after being dispensed on the preheated stator and fully penetrating the slot area, saturating the interns. This viscosity gain holds the resin in place and does not allow the resin to drip or move onto unwanted areas on the lamination steel through the non-heated trickle area and into the bake zone. This provides a clean, cured, finished stator that does not require additional cleaning. Using DSC analysis, the EPIC laboratory conducted testing to show the cure speed of the E240 epoxy. This graph shows the ProPreg E240 cure time at a temperature of 165 C achieves a degree of cure above 90% in only 3 minutes, and at 7.5 minutes, the degree of cure is above 95%, which is typically considered fully cured. When increasing the cure temperature to 175 C, the E240 reaches a 90% cure in 1 minute and reaches a 95% cure in 3 minutes. This reduces the time to a 95% cure by over 50%, with a 10 degrees C increase in bake temperature. This data is important as quick cure at 165 C and 175 C will allow manufacturers to increase throughput on existing process equipment or reduce the footprint on new process equipment in order to get the desired production rate. Here's what a typical trickle application process looks like. On the right, you see where the part is loaded, typically by hand or robot. Next, the stator will travel into the preheat zone while rotating at 10 to 20 RPMs. The stator is typically preheated to between 80 and 100 degrees C. Time needed to get the part to temperature depends on the mass of the part. It typically takes 30 to 45 minutes to reach the desired temperature in a convection oven. Other heat sources, such as induction or resistance, can be used to shorten the time to temperature. Once preheated, the stator exits the oven and enters the trickle area. This is a non-heated zone. The ProPreg E240 is dispensed precisely. The dispense rate is determined by how fast the windings accept the resin. Typical flow rates are in the 0.5 grams to 5 grams per minute range on rectangular PEEK-coated wire used in hairpin designs. There are multiple dispense positions, typically 3 to 6 index positions where the ProPreg E240 will be dispensed. These positions will likely have different nozzle placement, ID, OD, cuff paper, center, and end of conductors in order to achieve optimum slot fill and resin penetration. It is important to note that the E240 will not appear to smoke upon the initial trickling of the resin. nor will any detectable odor be present in the trickle or bake zone, as the E240 is a zero VOC material. The typical smoke and odor noticed with a polyester resin is due to the volatilization of the monomer. Once in the bake zone, the E240 is rapidly cross-linking. Bake zone temperatures are typically lower with the ProPreg E240 at between 155°C to 175°C. This is an advantage over higher temperature curing polyesters by allowing customers to either increase index times in existing equipment or lowering temperatures in the bake zone. The E240, when compared to a polyester, can increase throughput and reduce energy consumption. After going through the cure zone, the part enters the cooling zone. This can be forced or chilled air. Regardless, a lower bake temperature will provide a cooler part when the stator exits the oven. Overall, ProPreg E240 can reduce process time, increase throughput, minimize odor in the oven area, and eliminate cleanup of the lamination steel when compared to the industry-leading polyester. As part of EPIC Resins development work to provide a solution for overcoming the shortcomings of polyester resins and improving the adhesion of the secondary insulation to PEEK-coated conductors, EPIC teamed up with Solvay Specialty Polymers. Solvay is a major manufacturer and global supplier of PEEK engineered plastic, which is supplied to magnet wire producers to make PEEK-coated wire. Solvay also produces PEEK films, which are widely used as slot liners and phase insulation in the production of EV stators. This technical paper reinforces the superior mechanical strength of ProPreg E240 to PEEK-coated magnet wire and PEEK slot liners, both in ATF liquid and ATF vapor, aged at 150°C for 2,000 hours. Please feel free to scan the QR code to download a copy of the technical paper or through the other methods listed. Based on the challenges provided to EPIC Resins, we were able to achieve the results that the industry needs. EPIC Resins is able and ready to be an extension of your engineering team. Our philosophy has always been to listen to your needs and develop quality solutions to meet your challenges. We will formulate or provide a material to fit your specific or unique product. With over 100 years of combined experience, our team of seasoned chemists is ready to use our extensive testing equipment as well as our meter mix dispense equipment to meet your engineering timelines. Our qualified technical sales team will partner with you to provide the right material. Thank you for attending this webinar, and please contact us with any questions.